finally at tunnels. Okay, tunnels is a very simple concept, except there are some caveats. Okay, all right. When we run a simple tunnel, okay, we call it General Routing Encapsulation, or GRE tunnels. Okay, all right. Now, how do I explain a tunnel? Okay, well, first of all, we have our source IP and our destination IP. Okay, that is written or encapsulated over top of our source MAC address. I'm sorry, backwards, which is encapsulated over the IP source and destination IP with the layer 2 information. Okay, so going from right to left, if we're looking at this blank screen, okay, we got layer 2, layer 3, layer 4, layer 5, layer 6, okay, alright, but every time we put a header, okay, on the previous layer, like putting a layer 2 header on top of a layer 3 header, we call that encapsulation, okay, because when the packet arrives, okay, the first thing it's going to see it's whatever is in the front, okay. So if our data is back here, all right, okay, think about it as, got it. Okay, if our data is here, right, whatever I put in front of it, okay, is encapsulating that data. Okay, so if my layer 3 information here, which is source IP and destination IP, and I put a layer 2, which is my source MAC and destination MAC, layer 3 is now encapsulated with the layer 2. But here's the thing. With GRE, we are encapsulating the original layer 3 header with another layer 3 header. Okay? Because there's a reason for that. Alright? The original layer 3 header, okay, is going to say the source and destination, okay, of the beginning and the end of our tunnel. Okay? Meaning the source and destination of our tunnel. Okay? The layer 3 that's been encapsulated over the layer 3, okay, is going to have the tunnel information, the source and destination of the IP address of the tunnel. Okay, because the tunnel is virtual. All right, it doesn't exist in the data path of how the traffic must travel. So from router 1 to router 2, consistency, or I should say, from its mindset, okay, it believes there's a tunnel between those two interfaces, which it is, okay, all right, but when traffic arrives, okay, it is going to actually be told what is the source and destination of the packet. And I said this backwards, okay? The first layer 3 information is going to be the IP address and destination, the source and IP address of the tunnel IP addresses, and then the layer 3 over top of that, okay, which will make sense. That's going to be the actual source and destination of the real IP addresses of your devices, so communication from end to end, back and forth, can happen. Okay, if I had it backwards, it wouldn't work. Was that make, what originally I said it was backwards, the way I said it was backwards, but I'm sorry about that. Okay, so you gotta understand. So tunnels are very simple. So let's go into here. Okay. All right. And what I'm going to do is bring up the lab. Okay. And I'm going to create a tunnel interface from router 1 to router 3. Now, before I do that, think about the tunnel being built from my house to your house. Okay. I'm going to give the installer of that tunnel my source IP address, and a destination address, which is your house, okay, and he's going to build a tunnel underneath those two locations, and you and I can walk between underground from your IP from your address to mine. Now you gotta understand, okay, that tunnel is built because a foundation of ground exists. If that foundation of ground caves in, that tunnel is no longer up and active. Okay? So, we got to understand, if I build a tunnel, okay? Now we're going to draw it like this. Okay. Line. Okay, and I like to build my tunnels like that. Okay? If, and we also got to give this a name, which is going to be tunnel 1. Oops. Tunnel 1. Okay? Okay, so first of all, we're going to fill that up with green here. Okay, so remember, our first layer 3 packet is going to be the source IP address of 10.1.1.1, which is my tunnel address, and a destination of 10.1.1.3. Okay, but in order for the packet to reach its destination, okay, all right, the ground, all right, must be stable, meaning that over top of that layer 3 header, I'm going to write another one, and the destination is going to be 65.1.1.3 and 64.1.1.1 for the source. Okay, so regardless, even though router 1 and 3 believes it has a directly connected interface via called a tunnel, okay, it still has to transit the physical way of getting to that destination, hence the ground. Okay, if this IP address or this IP address is learned on either one of these routers through the tunnel, that tunnel is no longer stable because the destination or the next hop on the tunnel is going to be, okay, something that isn't created because the, okay, how do I say this? Let me restart. The foundation of the tunnel is based on the physical hop by hop basis to get to the destination and to the source via back and forth. Okay, that's what brings the tunnel up and stable. And then I can move traffic across their tunnel logically. However, I still have to go the physical path. Okay, if it takes 55 hops to get there, it does not make your traffic move any faster. It still needs to go down that path. If any of that path is broken, the tunnel will fail. If your destination of the other side of the tunnel is learned, which will be either this IP address or this IP address that forms a tunnel. If it's learned through the tunnel, guess what? Okay, the tunnel can't be active and up if it doesn't know how to get to the actual end of the tunnel from its source. So your tunnel will go down. So what will happen is your tunnel will bounce. Okay? Because this IP address here that's learned from here is being learned through the tunnel. That's what brings the tunnel down. Alright? Then the tunnel comes down. Now, because of that, this IP address comes back into the real routing table, okay, and brings the tunnel up. But then this IP address is learned through the tunnel, brings it down. And it'll just keep doing this over and over and over and over. So make sure that your sourcing destinations, okay, technically your destinations of the other side of the tunnel is not learned through the tunnel. Okay? That is one of those caveats. Okay? So now, what we're going to do is we're going to go into here. And create a tunnel interface. Give it an IP address of 10.1.1.1 and just make it a /24. Okay? And now I'm going to say tunnel source. Okay? That's going to be 64.1.1.1.1. Where's my mouse? And tunnel destination. .1.1.3. Okay? Done. Now our tunnel comes up because the commands are done. Alright? Interface tunnel 1, IP address, .1.1.3, okay, tunnel source, okay, 1.3. Alright, and then tunnel destination. Okay, now let's see if we can ping .1.1.1, and we succeeded. Okay, do show IP interface brief, and there's our tunnel interface, and it's up and up. Okay, as simple as that. Tunnels are just that simple, and they're very, very powerful because whether you know it or not, you can encrypt the traffic that goes across the tunnel. Alright, and that traffic is going to be encrypted regardless if it takes, which is going to do anyway, takes the physical path to get to the destination. It's going to be encrypted as long as your crypto information or configuration is matched on both sides. Okay? Alright, this is very powerful because if I had a scenario where I was setting up tunnels between all my branches across the internet, I could create my own entire network that's encrypted and private, okay, and build my own internet using the existing internet by using encrypted tunnels. Tunnels are so powerful, okay, and think about it from a perspective that, all right, you have a main headquarters and you got 10 sub offices all around the world. Okay, so instead of trying to figure out, okay, what's going on as far as from an IP perspective, create tunnels, all 10 tunnels from your headquarters to all your sites. Okay, all right, going to the headquarters router and pinging every one of those tunnels, okay, on the other side of the tunnel, shows you that you got IP reachability. That means the ISP on one of your branches is up and running. Everything is good. Okay? And plus, you have a direct connection to each one of those because in the description of the tunnel, you're going to type in description site 2. Okay? Or site 1. Right? And that gives you the ability to let you know that you have full convergence up and running and nothing's going on from a connectivity perspective. The ISP at one of those sites go down, your tunnel's going to go down. It's not going to work. You're not going to be able to ping it. Okay? All right? Giving you an indication there's something wrong with your communication from end to end. Tunnels are very powerful. Okay? And most people don't utilize them as they should. Okay? It's like, I can't tell you how many times it's something I say on a regular basis. Well, let's just create some tunnels and encrypt those tunnels. Okay? All right? Even from a consultant point of view, the customer doesn't really understand how powerful that is. Okay? Unless you explain it in a way that you can communicate from site to site without having, okay, MPLS or ISP service. Okay? You can use routing protocols within the tunnels, okay, which means I can run OSPF, the EIGRP, okay, have full reachability from a routing protocols perspective, okay, and it's encrypted. No one can read your data going from site to site. You are protected. It's like having your own private network over top of the internet. That is private and secured. Okay? Nothing beats a tunnel. Okay? And that's pretty much it. And I'll see you guys on the next one.